Okay, does everybody have a calculator? You might need to borrow one, because you definitely need to have one for today's lesson. Okay, so as you can see from your notes paper, we're talking about residuals. Somebody tell me, how do you find a residual?
Actual minus the predicted.
Good. So actual minus predicted. That's how we find a residual. What does it mean if the residual is positive? Does anybody else know? You underestimate. Good. That means the actual was more than they predicted. We predicted a value that was lower than the actual value. What about if it's negative? You overestimate. Good. So these are things that you should kind of already know, have an idea about. So we're going to go back over some of this, but some of this is review, some of it is new. So a residual is how far a predicted value is from the actual value, the data. So when we are doing linear regression, we come up with this line that is our least square regression line that we think is a good fit for our data. Our residuals tell us how close it fits. How far are we missing by? We want those residuals to be as small as possible. That way our line fits better with our data. So we're missing by less. We already talked about how do we calculate the residual. Was the actual minus predicted. So when we have a regression equation, we can find our prediction for any value by just plugging the value in for x, and our equation will give us a y value that is the estimate of what we think will happen. Then we can look at our data and see, well, what actually did happen at that value, and we can find the difference between the two. So, if a value is above the regression line, we're going to have a negative residual. Which means we overestimated. If the value lies below the regression line, then it's a positive residual. Where the model underestimated. So you want to just remember, basically, if it's a negative residual, it's an overestimate. Positive residual is underestimate. We want to make sure those things go together. Because it's often that they may ask you, interpret what it means for this equation to have, or this data value to have a residual of negative 14. Okay? That would mean, if it's negative, we overestimate. So this would say the model estimated a value that was 14 too big. Okay? So you need to be able to tie those things together. Okay. On our next part, where we're talking about a residual plot, this is kind of where we're going to be focused today, is looking at the residual plot. So a residual plot is a scatter plot. So on your calculator, you're going to use the scatter plot setting. For the type of graph will be the scatter plot. And we use the x values of our data. And the y values will be the residuals. So on our x-axis, we'll have the x values from our data set. The y-axis will be the residuals. So for each x value, we want to get a predicted, and then we want to subtract actual minus predicted, get that residual value, and graph it. Okay, so we'll go through an example of that, so you'll see how it works. When we analyze the graph, if the original data is linear, so this is a way to check, should a linear model be used? Because sometimes when we're looking at these, we're like, well, I can sort of see a curve, but I don't know if it's really a curve, or is it just there's a little gap in the data there. So a residual plot will really amplify those curves if there is one. If it's linear, it will show that. So a residual plot is a good place to check to see, is the data linear? So if it is linear, your regression line fits the data well, the residual plot should be randomly scattered. In other words, no pattern. So typically when you graph one of these, we'll have the x-axis, and then we'll have, if it's randomly scattered and there's no pattern, we should have some positive residuals, some negative residuals, and they should be scattered all around. So our graph is just a random scatter of dots where we don't really see a pattern. Some are positive, some are negative, they're just everywhere. This is our goal. We want to see this because that means our LSRL is a good fit. We can use it to make predictions. This is what we want to happen if we want to try to use that regression equation. And most of the time it does. Okay? Most of the time it's going to be good. Most of the data we look at is going to be linear, but you will have some that's not linear. So if that happens, if the original data is not linear, and you should not be using this regression line, then your residual plot should show a pattern. And really this pattern could look like anything where there's a pattern. There are three that are the most common ones that we'll see, so I'll show you a sketch of what those look like. The first one we'll look at where it looks kind of quadratic. It's negative on the ends, positive in the middle, so it has this curved pattern in the residual plot. That one is probably the most common one that we will see, where we see a curved pattern. Another one that shows up, not quite as often, but it does show up, is just a linear pattern. On the smaller values, we're getting residuals that are positive, and on the bigger values, the residuals are negative. So we're missing by a predicted kind of pattern. This last pattern is where it starts off and it looks like we're not missing by much. We have small residuals, but the further out you go, the more spread out it is. So it kind of has a fanned out pattern. It starts really close and then fans out to positive and negative on one side. So this is kind of we call it a fan pattern. Usually one of these three, either a curved pattern, a linear pattern, or a fan pattern. Questions up to here? Okay, we're going to go over to this other side and look at the example, and then we'll come back to that other page here in just a minute. So here we're going to look at this example. This is data for iPhone sales from the year 2007 to 2015. So we're looking at the debut year for each of these iPhone models and how many units were sold in millions. So go ahead and enter this data into your calculator. So the year will go in L1 and the units sold will be L2. So go ahead and enter that. Once we get that in, we want to plot our data. So we want to select the scatter plot L1, L2, and then zoom 9. So we're going to see a sketch of what this looks like. So over here on your paper, you notice it says to sketch the graph. If it says just sketch it, then you can just put basically a screenshot of your calculator. You can just sketch that onto here. If it says create a scatter plot, you need to be more detailed. You need to put scale along the X and Y axis. You need to show all the values in between. So if it says create a scatter plot, that means be more precise. If it just says a sketch, then you can just kind of give a rough sketch. So here we're just going to give a sketch of what it basically looks like. So when I do this, I'm going to get and to get the values, I hit the window button underneath the screen here, and that will give me my max and min for X and max and min for Y that I can use to label the edges of my graph. Any questions up to here? We're getting the graph. Okay. Go into your stuff. Okay, so are you all good up here? You're able to get that on your calculator. Okay, so if we are going to describe this, when you're describing a scatter plot, you need to talk about the strength, the direction, and the form. So is it strong, moderate, weak? Is it linear, nonlinear? Is it positive or negative? Those are the things we need to talk about. So what do you think for the strength? Would you say strong, moderate, or weak? Strong. What would you say about positive or negative? Positive. What about linear or nonlinear? Okay, so that's what we're going to write here and in the context of the problem. So, we're going to say the scatter plot shows a strong, positive, linear relationship between the year and iPhone sales. So anytime they're asking you to describe the relationship on a scatter plot, that's what they're wanting. Those three things, context of the problem. Okay, if I want to get the least square regression line, how do I do that? How do I get that on my calculator? What buttons do I push to get it to do this for me?
Alright, so you push stat,
Yep.
and then you go to help, push 8, enter, or whatever, I don't know, you got different calculators.
There we go.
Calculate. There you go, right there.
Boom, right there. Good job. Okay, everyone needs to do that on their calculator. Don't just write down my numbers, because for us to do the next thing, this has to have been done on your calculator, or it's not going to have what you need to have. So do those steps on your calculator, and then you should be able to write out the equation. Remember, we always write the equation with the variable names for x and y, not x and y. So here we'll have units with a hat over it to show us a predicted. There's my equation. What is the value of the correlation coefficient here? Yeah, 0.9559. What does that tell us? Strong and positive. Okay? So R can only tell you about strength and direction, not linear or nonlinear. So you want to make sure you make that distinction between what a scatter plot can show you and what R can show you. So, we get up to here. Now we want to use this equation to find the residual for 2007. So to find a residual, we need to do actual minus predicted. So we know the actual value for 2007 is 0.5. We need to calculate a predicted value so we can subtract them. So we're going to plug in the 2007 for the year and see what our prediction is. Okay, so when I did the calculation, my predicted number of sales would be negative 1.3978 million units. Okay, so now we need to find a residual. So the residual equals actual minus predicted. So the actual was 0.5 minus the predicted, negative 1.3978. So my residual is a positive 1.8978. So what does that mean? There you go. We had an estimate that was lower than the actual value. We underestimated the number of sales. Okay? So the model or the equation underestimated sales in 2007 by 1.8978 million. That's a pretty big underestimate, almost 2 million off. Are we okay with how we got that and how we explain what it means? So by now you should be able to decide, did it overestimate, did it underestimate? How much did it do either way? And what does it mean? So what we're going to do now is we're going to go ahead and explore what would this residual plot look like. So in order to do that, I need to look at, this is the data that you already have entered in your calculator in L1 and L2. We want to get a prediction for the number sold for each year. So we're going to let the calculator do all the difficult work and all the calculations. So you already have L1 and L2. What we're going to do is in L3, we're going to enter this equation just where it says year. You're going to say, well, the years are in L1, so we're just going to put L1 right here. So go up to where L3 is highlighted, and then just type in that equation with L1 for the year. You can see here where I typed it in using L1 for the year. Then when you hit enter, it's going to fill in that column. You'll have all of the predicted values right there. Okay, so this is what you're going to write in this column. So all of those numbers in L3, you're just going to write into your predicted units sold. Yep. Okay, so once you get those, we can get our residual because we're just subtracting our actual minus predicted. So you're just doing your L2 minus L3. So over here for L4, you can just do L1 or L2 minus L3. And it will calculate all of those residuals for you. So these are going to be this last column, the residuals. Okay, so to make our actual residual graph or residual plot, what we're going to do is use our x value, so our year, and our residual is the y. So in 2007, the residual was 1.89. So in 2007, right about there. So in 2008, we had 0.79. Right about there. 2009 was negative 0.8. 2010 was negative 1.7. 2011 was negative 1.0. And then 2012 was negative 1.6. 2013 was a positive 0.76. 2014 was positive 0.16. And 2015 was a positive 1.55. So we get something that looks like this. So we want to know, is this equation that we came up with here, is that a good fit? Is that an appropriate model? If it is, this should be randomly scattered and not show a pattern. What are we seeing in our residual plot? Is there a pattern? Yeah, it definitely looks like this curved pattern happening. So, do you think this is a good fit? No. Because the residual plot has a pattern. So if you are asked, is this regression equation a good model for the data? That's what you need to do. You need to do a residual plot. You need to show it on your paper. You can't just say, I did this on my calculator and this is what it looked like. Trust me, I did it. You have to show it on your paper what you got. So a sketch on your paper of the residual plot, and then a statement saying it is a good fit because the residual plot is randomly scattered, or it's not a good fit because the residual plot has a pattern. Okay, so one or the other is going to be your justification. Okay. Questions on that part? Okay, let's look over here at this one that we haven't done yet. So on the calculator, your calculator will do this residual plot for you without you having to do the L3 and L4 and calculate all of those things. You just must do the LINREG first. So highlight that, mark that, make sure you remember this must be done first, or else you're going to get an error. You'll get to this error and you'll be like, why? I'm doing the right things. Why isn't it giving me this? And if it's a quiz, I won't be able to tell you why it's not giving you that. So do the LINREG first. So has everyone done that for this data? Everyone has done the stat calc number 8 LINREG. Okay. So then what we're going to do, we're going to go into our stat plot. And you do this exactly like you would do the scatter plot. So we select that scatter plot as the type. We do L1. And then we want our residual list for L2. Now once you do that stat calc number 8, it creates a residual list for you. You get to it by right here on stat. You see up above there is list. So second stat. And you should have one that says resid. So number 7 on mine. It may be a different number on yours. But it should be RESID. That's our residual list. Once you get this set up, then you should just be able to do zoom 9. And it should graph something that looks like what we did in our residual graph.
How do you get the residual into that?
Second stat,
Okay.
and then go down to resid.
Just plug it.
Uh-huh.
Oh.
And then we'll put it in there. And then just zoom 9. It should do the graph.
Yeah.
Okay. Anybody not able to get this to show up? So this is going to be how you do this on the calculator. Now when you do this on the calculator, like I say, you can just do a rough sketch. Normally you don't even have to do like a scale for the X and Y axis. You just need to show the pattern. There either is a random pattern where there's no pattern, or there is a pattern. You just need to sketch what the dots look like so we can verify there was a pattern or there's not. Okay, so this went on page 98 in your notebook. You want to go ahead and attach that page 98. And then your problem set that is in your folder is going to go on page 99. So make sure you attach that and do it tonight.